So today should be March 8th. Should have a sub today. So, sorry I can't be there today with you once again. This video is just going to be a quick review of kind of what we talked about yesterday. It seemed that we had a lot of, or it seemed a lot of you were working on the one side of the review yesterday that had the graphs and we were finding the 3 key features. And so for today, I just want to review over that. Just go over how do we find the key features from a graph, how do we find the key features from the equations, review those steps again, once again, and then hopefully this will help clarify little things and help you be able to review a little bit on your own on the worksheet after this. So, looking at what we have, we want to find 3 key features of the quadratic from this graph. Once again, our 3 key features are our y-intercept, our x-intercept, and our maximum or minimum. Once again, you only have either a maximum or a minimum. We can never have both, but we're going to figure out what one we have in this situation. So let's start off with the y-intercept. So our y-intercept is, once again, always where our graph touches that y-axis. So if we look at our y-axis, we have we have y with the top that looks more like an x. So we have y on the top and x on the side. So we cross this y-axis right here, which, if we look at the coordinates, is 0, 2.5. So 0, 2.5 is our x, or our y-axis. That's where we cross that y-axis. So it's simple enough. We look at our graph where we cross the y-axis. That's it. If we're looking for x-intercept, where do we cross the x-axis? We look, here we go. I have one spot down here at -1, 0. And then my other spot, because typically we have 2, not always, but typically, and this one is at 5, 0. These are my 2 x-intercepts that I got. And then the last key feature I have is my maximum or my minimum. Now, once again, depending on what the graph is shaped like, will determine whether we have a maximum or a minimum. If our graph is positive and it's facing up, the top of our graph will keep going up and up and up, and we'll never get a total maximum. But we'll always have a lowest point on that graph. So that if our graph is positive, we'll have a minimum value. But if our graph is negative, going down, then we'll have that maximum value at that very top. So looking at our type of graph, we are going, because our graph is going down, opening downward, we are going to have a maximum for our type of graph. And if we look, the highest point on our graph is going to be that vertex way up here on our graph, way up at the top of the curve. And if I look at the coordinates of that, that is 2, then 4.5. 2, 4.5 is that point. 2, 4.5 is my maximum of my graph. And that's all I need to do from looking at a graph to find my 3 key features. Once again, y-intercept, look to where we cross the y-axis, put the coordinate. X-intercept, we look for those 2 spots we are typically crossing the x-axis. Then we have 2 points, rotor coordinates. And then our maximum, minimum, we look at where's the highest point on a graph, where's that lowest point on the graph, depending on how the graph is facing. And so we found it to be 2, 2.5, or 2, 4.5 location. So that is finding our x or our 3 key features from a graph. Now let's talk about what happens if we have an equation. So we have the equation of the quadratic. We want to find the key features. One thing you can do is you can graph this on one of our graphing calculators, and then you can look for, okay, what's my y-intercept, what's my x-intercept, my min-or-max, and you can use little trace features to be able to locate those. That is one possibility, or just look at the grid. But sometimes it's hard to get the quadratic to fully graph on the grid. Sometimes we can only see part of it, and so we can't fully rely on the calculators on all the time. So if that's the case, we want to be able to do it using a little algebra as well. So step number 1, we want to find the y-intercept. So our y-intercept is always going to be 0 and then some coordinate where we cross the y-axis. And the unique feature with quadratics is when x is 0, this would become 0, this would become 0. The only thing we'll have left is that last number. So that last number is always going to be your y-intercept. So that's c value, because remember we talked about it's ax squared plus bx plus c, and so that c, which in this case is negative 12, is going to be your y-intercept. So it's always 0c, whatever that number is. So y-intercepts are pretty easy. We just look at that last number. X-intercepts take a little bit more work. So x-intercepts, we're looking, when is this quadratic going to hit the x-axis? When is the value equal to 0 at the x-axis? So we need to solve this. Once again, in order to solve this, we're going to have to use our factoring skills. If we look, I have a number in front of my x squared, so that means I'm going to have to do my longer method of factoring, but that shouldn't be too bad. We can practice that. So, step number one, I'm going to create my x. I need to take my first number and my last number, multiply them together. That gives me negative 24. That's going to go on the top of my x. Then I know my middle number is going to go on the bottom. So that'll be my bottom one. So I need to think of two numbers that multiply to get negative 24 and add to get 2. So we start off by thinking of some factors of negative 24. Some factors of negative 24 are, let's see, 2 and 12, but that's not going to combine to get 2. 8 and 3, but that's not going to combine to get 2 somehow. 4 and 6, we can do 6 minus 4, multiply together will give you a negative 24, and add together to get a positive 2. So now that I came up with my two factors for my 24 and 2, I can now rewrite my problem by splitting the middle. So I'm going to have 2x squared plus 6x. I'm rewriting that 2x into a plus 6x and a minus 4x. And then my last part is still a minus 12. So I rewrote my problem. Now I can group the first two, group the last two, and then I'll think, okay, what factors do I have in this first group? Or what's my GCF for this first group? Well, they both have a 2 in them. They both have an x in them. So 2x, if I rewrite 2x squared divided by 2x is just a single x. 6x divided by 2x is plus 3. If I look at my next group, I'll have negative 4x minus 12. From here, if I factor out a negative, let's see, they both have a negative 4 in them. So I factor out a negative 4. Negative 4x divided by 4 is just x. Negative 12 divided by 4 is a plus 3. If you thought of just taking out a 4, we would have a 4 plus 4, and you would have a negative x, a minus 3, so we could just switch that around and that should get the right thing. So here we go. We have x plus 3 as one solution, that's my inside. And then I have 2x minus 4 as my other solution. 2x minus 4. And once again, we're looking for when was this equal to 0 up here. So I need to remember that because this factor right here are the exact same thing as what I had up here, just not multiplied together. But this also equals 0. So I need to start thinking, okay. Oh, let me pause that. Sorry. All right, sorry about that. All right, so once again, these two multiplied together equals 0. So because of that thing we talked about on, let's see, it would have been Tuesday, we talked about the zero product property. So the zero product property says the only way you can get two pieces to multiply together to get 0, the only way you can get two things to multiply together to get 0 is if one of those two pieces are equal to 0. So what that means is that either x plus 3 has to equal 0 at some point, or 2x minus 4 equals 0. So we're looking for when are both of these, or when are these going to be equal to 0, and that will tell us when our whole quadratic will equal 0. So in order to solve x plus 3 equals 0, I just have to subtract 3, which is x equals negative 3. And for my 2x minus 4, I just need to add 4, the two-step equation, which gives me 2x equals 4, and then divide by 2 to get x by itself, which is x equals 2. So at 2 and negative 3 is when my quadratic is hitting that x-axis. So at 2, 0, and negative 3, 0 are my x-intercepts. So once again, just like for a y-intercept, anytime we need to solve for these x-intercepts, factor that quadratic. Sometimes we might use the longer method. Sometimes we might need to use the shorter method, but we'll split the middle in this case, find both of those solutions, and then those will be your two x, those will be x coordinates, and then your y coordinates for each of these points will always be 0. Last step is we're looking for that minimum or maximum. We actually know, in this case, that we have a maximum for our quadratic because, once again, that number in front of our x squared determines whether we're going up or going down. Because that number is a positive, I know my quadratic will be going up, it will be positive, so I will have a minimum. I'm sorry, I circled the wrong thing. I said we have a maximum. We will have a minimum of the quadratic because it was positive. So now we need to figure out what actually is that minimum. And so what we can do is we have this little equation, or we have this little rule, that if we find, or we know the x coordinate, sorry about that once again. So what we've learned is that the x coordinate of your minimum or your maximum point on your quadratic will always be equal to the opposite of b over 2a. Once again, this b and this a comes from our ax squared plus bx plus c. So we're going to pull those values and put them in for b and a to figure out what is actually this value. So x equals the opposite of b over 2a. So x equals negative b, which if b is 2, x equals negative 2, divided by 2 times a, which a in my quadratic is 2 as well. So I have negative 2 divided by 2 times 2. Well, 2 times 2 is 4. So I have negative 2 divided by 4, which will give me negative 0.5. So negative 0.5 is going to be the x coordinate of my minimum point on this quadratic. So that's my x coordinate. In order to get my actual coordinate of my quadratic, my y coordinate, to figure out what is the height of my quadratic at that point, I'm going to have to take this number, I'm going to have to plug it back into my quadratic, evaluate my quadratic at this point. So my quadratic is normally 2x squared plus 2x minus 12. I'm trying to figure out what happens if x is negative 0.5. So I am going to rewrite this, but instead of having x's, I'm going to put negative 0.5 in there. And from here, one easy thing is just typing this whole problem into the calculator and having it evaluate it for itself. 2 times negative 0.5 squared plus 2 times negative 0.5 minus 12. You can type that whole thing in the calculator and have it solve it for you. That's one way to go about this. Another way of going about this is just solving by hand, like what we can do. So negative 0.5 squared, once again, anytime a negative is squared, it's going to give you a positive. Because the negative times the negative gives you a positive. So negative 0.5 times negative 0.5 is going to be 2 times 0.25. And then 2 times negative 0.5 will give you negative 1. And then we'll have this minus 12 there. So we still have to multiply these two together. So 2 times 0.25 will give you 0.5. And once again, you can do these on the calculator if you really need to, or if it gets to that. And so we have 0.5 minus 1 minus 12, which we subtract all that together. That should give us negative 12.5. Negative 12.5. Once again, that is the y coordinate of my minimum. I found my x coordinate to be the opposite of b over 2a. Plug that number back in for my y coordinate. And so my coordinate, my final coordinate for my quadratic, for my minimum point on my quadratic is negative 0.5, negative 12.5. So once again, we can do this anytime we're looking for a minimum or maximum. It works from either point. It always finds that vertex, that curve point of your quadratic. So I know we did a lot of math here. We've done a lot of different things to look for. But this is what we're going to be practicing today. So you're going to get some practice. You're going to be looking for what is the y-intercept, x-intercept from a graph. And then on the back side, you should have what is the x-intercept, y-intercept, maximum, minimum, all that stuff from quadratics and from the function. So practice all of this. If you have questions or if you find a question that's like really tough or really hard, put a star next to it and ask me about it on Monday. We can review some of the stuff. We'll talk about some of the stuff. And I will see you over the weekend. Or after the weekend, sorry. So have a good one, and I will see you on Monday.